Hello guys, how are you today? So today I'll be explaining the chemistry AMS of term 1 week 2. So this is grade 11, grade 12 AP chemistry. Now just to inform you, I'm also going to be doing AS Chem. So for anyone taking AS Chem, I'll also be explaining the chemistry AMS. So let us start with the first question in AP Chem. Which of the following are the factors that affect the magnitude of the lattice energy? Whenever they say magnitude of the lattice energy, this is denoted by E. Released when a pair of ions attract each other. So one thing you need to know about this, whenever you see this type of question, you should know that it is derived from Coulomb's rule, right? So what is Coulomb's rule? First of all, Coulomb's rule is what? Is that the force is equal to the absolute value of the charge 1 multiplied by the charge 2 divided by what? Divided by the radius squared. So this is what? This is Coulomb's law, CL. But now let's apply this to what? Let's apply it to ions. If we did apply it to ions, we would say that the magnitude of the lattice energy. Why do we say magnitude? Because the charges are put in absolute value. This absolute value will ensure that it is a magnitude, right? Because magnitude will not have a direction. It's only magnitude. So with the absolute value, it will ensure the magnitude. So the magnitude of lattice energy E is equal to the absolute value of the charge of one ion multiplied by the charge of the other ion over what? Over the radii of the two ions. So R squared, or the radius of the two ions. Now, from this, let me just erase this 1 second. From this, what do we understand? Very simply, first thing that we can understand is that when something is in the numerator, it is what? It's directly proportional to something, right? So in this case, right, we have that the absolute value of the charges, okay, is in the numerator. So we can say that since it is in the numerator, okay, it is directly proportional. So since in numerator it's directly proportional, that means that E is directly proportional to the absolute value of Q1 times Q2. Now, we're dealing with this, R squared. R squared is in the denominator, right? So since in denominator, means the denominator, it is what? It is inversely meaning inversely proportional. What does this mean? This means that E, the energy or magnitude of lattice energy, is directly proportional to 1 over R squared. When it is 1 over R squared, then we say that E is inversely proportional. This means proportional to what? To R squared. Okay, so in summary, what can we understand from this? We can understand that E, the magnitude of lattice energy, is directly proportional to the charges of the two ions, and that E is inversely proportional to the radius of the two ions. So these are the two correct answers. Let's move on to question number 2. What does it say in question number 2? Thorium, TH, has 7 naturally occurring isotopes. First of all, what are isotopes? Isotopes are atoms of the same, pay attention, same element, right? So isotopes, they are what? Atoms of the same element. They both have to be from the same element. It cannot be thorium and potassium. No, it's only thorium. So it's all thorium, thorium, thorium. It cannot be what? Thorium, potassium, magnesium. No, it has to be all of the same element, right? Having atoms of the same element, having the same atomic number. What is atomic number? This means the number of protons. Of P plus means protons. But a different mass number. So isotopes are atoms of the same element having the same atomic number, which is number of protons, but a different mass number. How is it possible if they have the same atomic number in order for them to have a different mass number? If they have a different mass number, this is due to what? Due to a difference in what? In number of neutrons. Okay? So Isotopes are atoms of the same element having the same atomic number, which is the number of protons, but they have a different mass number. Why do they have a different mass number? Due to a difference in the number of neutrons. Now, because of the different mass number, so because, this is C, let me just change, because of, this means different mass number. So because of the different mass number, or due to the different mass number, we can know what? We can know that they will have different physical properties. Why is that? Because if they have a different mass number, that means one is going to be heavier than the other, one is going to be lighter than the other. Of course, mass is a physical property, and because mass is changing, this means that they will definitely have what? They will have a different physical property. However, because of equal means the same, equal atomic number. So because of the equal atomic number, we can say that they have what? They have the same chemical properties. So again, a quick recap. Isotopes are atoms of the same element having the same atomic number, which is number of protons, but a different mass number due to a difference in number of neutrons. Because of the difference in mass number, they will have different physical properties, and because of the same atomic number, they will have the same chemical properties. So which of the following are true about isotopes of thorium? They have same chemical properties, they have different number of neutrons, they have same number of protons, however, they have a different physical property. Let's move on to question number 3. What does it say in question number 3? It says, thorium, Th, is a naturally occurring radioactive metal found at trace levels in soil, rocks, water, plants, and animals. Its atomic number is 90. Its what atomic number? Atomic number is denoted by Z. So its atomic number and mass number denoted by A is what? Is 232. Which is what? A possible isotope of thorium. First of all, let's write what we found. We have thorium Th with an atomic number of 90 and a mass number of 232. Now, what did we discuss about isotopes? Isotopes have same Z, which is atomic number, but different A, which is the mass number. So looking at all of the options, which one has the same atomic number? This is 91, we don't need it. 91, 142, 90, this is an option, and 142. So just like that, in 3 steps, we found what? We found the possible isotope of thorium. Let's move on to question number 4. What does it say in question number 4? Which of the following ions has different numbers of all 3 subatomic particles? What are the 3 subatomic particles? Protons, neutron, they have no charge, so N0, and then electrons, E-. So they're saying which of the following has 3 different subatomic particles? Let us see. Let's separate each one into different groups. Let's start first with the neutron. We'll find the number of neutron, then we'll find the number of proton, and then we'll find the number of electron. So let's start with this. First thing, of course, you need your calculators, by the way. First thing, we will start with this. How many neutrons do we have? We have 39 minus 19, which is what? Which is 20 neutrons. How many protons do we have? The same as the bottom, which is what? Which is 19. So the atomic number is 19. That means we have 19 protons. How many electrons here in this case? Because we have a charge, in order to find the electrons, it's going to be the atomic number 19 minus the charge, which is plus 1, and it will give us an answer of 18. So this has 20, 19, and 18. That means this is an option. Let's move on to the next one. How many neutrons do we have? 14 minus 7, which is 7. How many protons do we have? 7. How many electrons do we have? We have 7 minus 3, which is what? Which is 10. So definitely this is wrong. Why? Because neutron and proton is the same number. Let's go on with this one. This is 32 minus 16, which is 16. This is also 16. And this is what? 16 minus 2, which is what? Which is 18. Again, you have neutron and proton, same number. Because they're the same number, it's not considered. Then again, this one, 24 minus 12 is equal to 12. Then you have 12 over here. And then you have 12 minus 4, which is what? Which is 16. Sorry, not 4, 2. 12 minus 2, which is what? Which is 16. Now, because of this, we will say that this is also not an option. Why? Because neutron and proton have the same number. So what's our option? Our only option is 39K plus 19. Now, deduce the number of subatomic particles in each of the following species. Let's start with barium, 13756. First of all, what's the mass number? Again, this is any element. It's XAZ. A is the mass number, and Z is what? Z is the atomic number, which is what? Number of protons, P+. Okay, let us start with the first one. Miriam, what's the mass number? 137. What's the atomic number? 56. What's the number of protons? Also 56, because atomic number is number of protons. What's the number of electrons? Because it is an atom and it has no charge, okay, we will say that the number of electrons for it is 56. Okay, so only in the case that it is an atom and has no charge, okay, the number of protons will be equal to the number of electrons. Now, finally, the number of neutrons, how do we find it? 137 minus 56. Put it on the calculator, you're supposed to get an answer of 81. Let's move on to the next one. What's the mass number of aluminum? It is 27. What's the atomic number? It's 13. What's the number of protons? It's 13. Because it is an atom, it has no charge. You would say that it has the same number of protons and electrons. So this is also 13. Now, how do you find the number of neutrons? Very simply, it's going to be 27 minus 13. Put it on the calculator and you will get an answer of 14. Let's move on to the next one. What's the mass number? 80. What's the atomic number? 35. What's the atomic number? What's the number of protons? 35. Now here, what's the number of electrons? Here, the charge of this is what? Is minus 1. In order to find the number of electrons, it is what? It's the number of protons minus the charge. So 35 minus 1, which is what? Which is 36. So 36 electrons. Let's move on to the number of neutrons. It's going to be what? It's going to be 80 minus 35. Put it on the calculator and you're supposed to get an answer of 45. Now, last one, which is Fe2+. What's the mass number? It's 56. What is the atomic number? 26. What's the number of protons? 26. What's the number of electrons? Again, number of electrons. Here, how much is the charge? The charge is plus 2. So, it's going to be 26 minus 2, which is what? Which is 24. So, the answer here is 24. And then what? And then finally, in order to find the number of neutrons, it's 56 minus 26, which is what? Which is 30. So please remember this, write it down. I have it written down. So the answer for the first one is 137, 56, 56, 56 again, and 81. Then we have 27, 13, 13, 13, and 14. For the one after, we have 80, 35, 35, 36, and 45. Go to the one after. What do we have? We have 56, 26, 26, 24, and 30. So this is, oops, I think I went too far. This is what, these are the final answers, and this is what you're supposed to put. Let's move on to the next question. The atomic symbol of titanium, Ti4822. Which of the following statements about titanium is true? First thing we know, let us find A is 48. Let us find Z is 22. Let's find the number of a neutron, which is N. It's gonna be 48 minus 22, which is what? What's 48 minus 22? It is 26. And let's find the number of electrons. Because it's a neutral atom, we will have the number of protons is the same as the number of electrons, so it is 22. Let's see the options. We have that the mass number is 22. No, the mass number is 48. Number of protons is 26. No, it's 22. Number of electrons is 48. No, it's also 22. Number of neutrons is 26. This is correct. And then the atomic number is 48. No, it is 22. So the only correct thing we have is the number of neutrons, which is 26. Let's move on to question number 6. Copper, Cu, is a transition metal that has 29 protons and 35 neutrons. And how many neutrons? And 35 neutrons. Now, what is the atomic symbol of copper U? First of all, copper Cu. First of all, you will start with the element, which is copper Cu. Then on top, what do you need to have? You need to have mass number. Mass number is equal to proton plus neutron. What's our proton? 29. Plus, what's our neutron? 35. 29 plus 35 is going to give us 64. So you're going to have 64 in the top. And the bottom, you will have the number of protons, which is the atomic number, which is what? Which is 29. So the correct answer in this case is what? Is 64, 29 Cu. Here we go. Yalla, question number 7. What is the maximum number of orbitals that can be found on the third energy level? Okay, let's stop here for a second. When they ask us for the maximum number of orbitals, we have to follow this equation, which is what? Which is n squared, where n is what is the energy level. So if they ask us for the maximum number of orbitals, it's going to be what? It's going to be n squared. What if they asked us for the maximum number of electrons? If they ask us for the maximum number of electrons, it's going to be 2 times n squared. Only n is squared. 2 is not squared. Okay, so again, maximum number of orbitals, you will make it n squared, and maximum number of electrons, it's 2n squared. In the case where where n is the same as energy level. So in this case, they want the maximum number of orbitals, meaning we will use this equation, in the third energy level, right? So n, in this case, is how much? N is equal to 3. Just substitute it over here. So it's going to be 3 squared, which is what? Which is 9. So we have maximum of 9 orbitals in the third energy level. That's question number 7 done. Let's move on to question number 8. The surface of a metal is struck. Okay, look, here what you need to know is that we don't have too much time in the AMS, so you cannot read everything. Of course, you have to scan it, like read it, but don't take your time reading every single word. Scan it, see what we need to find. So over here, we will write what we need to find. And what is given, we will write it over here. First thing, what do we need to find? By scanning, we can see they are asking what is the wavelength. So we need to find the wavelength lambda. Okay, then again, by scanning, let's see what we have given. We have given the energy of the photon. So E is equal to 4.19 times 10 to the power of minus 19. Please excuse me, I'm not going to write the units, but of course you have to write the units. For me, they don't fit. That's why I'm not going to write them. But for you guys, of course you have to write it. Okay, now, what's also given? H, which is what? Which is Planck's constant, which is 6.63 times 10 to the power of minus 34. And then finally, the last thing that is given to us is C. C is the same thing as velocity or speed, but in this case, because we are dealing with light, okay, we will denote it as C. What's the speed of light in vacuum? It's 3 times 10 to the power of 8 meters per second. Now, how will we be able to find lambda in the case that we have what? In the case that we have Planck's constant, the energy, and C, which is the speed of light in vacuum. Very simply, you need to know some equations. We took similar equations last year in physics, and we're taking them again this year in chemistry. What is this equation? This equation is energy, okay, is equal to Planck's constant times V. What is V? V is not velocity. You can use V to denote anything. It can be velocity, it can be this. But in chemistry, what we are learning now, V is equal to what? V is equal to the frequency, okay? Now, after we find the frequency, if you guys remember, after we find the frequency, we can put it in the equation. We know what is the equation. We know that frequency times wavelength is equal to speed. So very simply, frequency is equal to what is equal to speed over wavelength. I hope by the end of this video, I'll be able to write the equations, okay? There are a couple of equations and only the SDPF thing. So that's all you guys need to know from this chapter, this AMS quiz for equations, okay? So, again, energy is equal to Planck's constant times V, which is the frequency, and then V, the frequency, is equal to the speed of light in vacuum over the wavelength. So how can we find the wavelength using these two equations? Well, very simply, let's see what we have. We have what? We have H is given to us. We have E is given to us. And we have C is given to us. So how can we use this in order to find what? In order to find lambda, which is the wavelength. Very simply, first thing we can do is we can find the frequency. So let's find the frequency, okay? What's the energy? Energy is 4.19 times 10 to the power of minus 19 joules. It's equal to what? It's equal to Planck's constant, which is 6.63 times 10 to the power of minus 34 times V, which is the frequency. Now move this to the other side. That means V is equal to what? V is equal to energy, which is 4.19 times 10 to the power of minus 19 over what? Over Planck's constant, which is 6.63 times 10 to the power of minus 34. So 4.19 times 10 to the power of minus 19 over 6.63 times 10 to the power of minus 34. We will get an answer of what? We will get an answer of approximately equal to 6.32 times 10 to the power of 14. Now, I'm going to erase everything here so we can have more space. I'm going to erase the given and what we need to find. And I'm going to erase this over here, okay? So we got what? We got that the frequency, V, is equal to 6.32 times 10 to the power of 14, what? Hertz. Why? Because Hertz is the unit of frequency. Now that we have the value of the frequency, let us use it in order to find the value of the wavelength, because all of this we are doing it in order to find what? To find the value of the wavelength. So V is equal to C over lambda. So that means lambda, what we're looking for, is equal to C over V, right? So what is C? C was given to us as 3 times 10 to the power of 8 over the frequency V. The frequency V, we found it over here, which is 6.32 times 10 to the power of 14. So 3 times 10 to the power of 8 over 6.32 times 10 to the power of 14. And we'll get an answer of what? We will get an answer that lambda is equal to what? It's equal to 4.75 times 10 to the power 10 to the power of minus 7. Okay, so using these two equations, what did we find? We found the wavelength lambda, right? What again was the wavelength lambda? It was 4.75 times 10 to the power of minus 7. Now this is what? This is in meters, but what do they need it in? They need it in nanometers. So how do we change from meters to nanometers? We multiply by 10 to the power of 9. So from meters to nanometers, we will multiply by 10 to the power of 9. So multiply this by 10 to the power of 9, you will get 475 nanometers. So our answer is what? 475 nanometers. Now, based on the table below, choose the correct color of light that caused the electrons to be ejected from the surface of metal. We found that the value was 475 nanometers. It's in between which wavelength? Again, of course, it has to be in nanometers. It's in between this wavelength, 424 and 491. So what is the color of this wavelength? It is what? Very simply blue. Okay, I will repeat this question. I won't repeat it, I'll just summarize it quickly. We have the energy, which is 4.19 times 10 to the power of minus 19. We have Planck's constant, which is 6.63 times 10 to the power of minus 34. And we have C, which is the speed of light in vacuum, which is 3 times 10 to the power of 8. They want us to find the wavelength, and from finding the wavelength, they want us to find the color. So we know a set of equations. What are the set of equations? The first equation that we know is that the energy is equal to Planck's constant times V, which is the frequency. And then using V, we can find lambda, because we know that V is equal to the speed of light over lambda. Using these two equations, we found the value of the wavelength. And after finding the value of the wavelength, we will see it's in between which two values? It's in between 424 and 491. And that means its color is blue. Now let's move on to the next question, which is question number 9. I don't think it's supposed to take too long to load. We'll just wait a bit. So we move on to question number 9. Nitrogen has how many electrons? It has 7 electrons. What is the correct electron box in box representation that has the lowest energy? Keyword here is what? Is lowest energy. Whenever they say lowest energy, according to Hand's rule, okay, this means it has the most unpaired electrons. So the one with the lowest energy always has what? Always has the most unpaired electron. So before we start with anything, you're going to take nitrogen 7 and we will do the SPDF notation of it, okay? This is a way I like to personally do it. We will do the SPDF notation. Now, if you don't remember the order, you don't need to memorize anything. There's 2 ways in order to do this. If you don't memorize the order of the SPDF, you can start very simply by doing S, then after S, you will have SP. Let me just put more space between them. Then after that, you will have SPD. Then after that, you will have SPDF. And then it's just more SPDF again. And then SPD. And then SP and etc. So let's stop here, okay? This is, we're not gonna use more than energy level 5, I believe. But let's do it until here, okay? Let's start by numbering. This is in which energy level? It's in the first energy level, so we label it 1. Then we move on. This is second, so we label it 2. This is in the third energy level, so we label it 3. This is in the fourth, so we label it 4. This is in the fifth, we label it 5. This is in the sixth, we label it 6, and so on, right? And what you need to remember is that S always has what? Always has a maximum of 2 electrons. P always has a maximum of 6 electrons. D always has a maximum of 10 electrons. And F always has a maximum of 14 electrons. Just remember, when the number is odd, you're gonna add 1. But when the number is even, you will keep it the same, right? What does this mean? Let's start. First of all, the number is even, so you're gonna take 1. You go from 0, you start with 1. Let me just change the color. You go from 0, you start with 1, so you're adding 1. Next, it's even, so you're gonna do the complete same. You took 1, you're gonna take 1, right? So how many did you take here? 1. In the even, how many did you take? 1. Now, you move to an odd number. This is 3, the third arrow now. So because it's an odd number, you're gonna add 1 more. So it's gonna be 1, 2. How many did you collect in this one? You collected 2. Now, you move on to the next one. It is what? It's even, so you will also take only 2. Now you move on to the next one. The next one is odd, so you're gonna take 1 more. So it's gonna be 1, 2, and 3, right? Let me just fix it, make it a proper line. 1, 2, and 3. How many did we take here? We took 3. We move on to the sixth one, the sixth arrow. Because it's even, it's gonna take the same as before. So how many did we take in the one before? We took 3. So here we're also gonna take 3. No, here it's like this. Here it's DPS like this. You're also gonna take 3. And then you move on to the 7th arrow. And then how many did you take here? 4. And then you continue so on 4. I personally find this way really confusing. Okay. And it's not confusing. It's just like long and boring. And if you do a mistake, you're gonna mess up. So I will give you a method. My chemistry teacher last year taught me this method. What is this method? Very simply, you start like this. You start by doing SS. Okay. Always remember SS. Now you go the opposite, but you add P. So what comes after S? It's P, but you will put it first. So PS, PS, right? So SS, PS, PS. After PS, PS, what comes after? It comes D. So DPS and then DPS. What comes after D? F. So FDPS, FDPS. So it looks something like this, right? Let me just make it a bit clearer. Okay, so this is what it's supposed to look like, okay? Now, after this, what do? We label. Always with S, it starts at 1, right? So 1, what comes after 1? 2, 3, 4, 5. Okay, so we labeled it. How many electrons is the maximum that S can take? It can take a maximum of 2. So 2, 2, 2, 2, 2 for each one. Now, after S, what comes? P. But P starts at the second energy level. So it's going to be 2P. Then what comes after 2? 3. Right? So, what's the maximum number of electrons that P can hold? P can hold a maximum number of electrons being 6. So now you will put 6 for each P. Now, after P, what comes? D. So D starts at the third energy level. It will start with 3. So after 3 comes 4. After 4 comes 5. And after 5 comes 6. Okay. What's the maximum number of electrons that D can hold? It can hold a maximum of 10. Right? Now, we move on to which one? We will move on to F. F starts at the 4th energy level. So after 4 comes 5. What's the maximum number of electrons that F can hold? It can hold a maximum of 14. So this is what it's supposed to look like. Okay, this is how I use it. I would suggest for you to write SS, PS, PS, DPS, DPS, FDPS, FDPS, okay, on the paper, right? So the first line, SS, second line, PS, PS, third line, DPS, DPS, and fourth line, FDPS, FDPS. And then you start, S is in the first energy level, P is in the second energy level, D is in the third energy level, and F is in the fourth energy level. And you have to memorize how many electrons each one of them can hold. Now, we're doing that. Nitrogen has how many electrons? It has 7 electrons. So if we were to do the SDPF or SPDF electron configuration, how would it look like? We would start by this one over here. So 1, S2, right? How many electrons did we take away? We took away 2. So how many do we need to have left? 7 minus 2, 5. So you finish with this one. We'll move on to the next one. What's the next one? To S2. How many do you have now? You have 4 electrons. So 7 minus 4 is 3. We still need 3 electrons. So now we move on to what? We move on to 2p6. But do we write 2p6? No, we write 2p3. Why do we write 2p3? Because we only need 3 more electrons. If you add all of the electrons, 2 plus 2 plus 4, 3, 2 plus 2 plus 3, you will get an answer of 7, right? And 7 is what we need. So 7 electrons, they are completely filled in this structure. Now, is this what they need from us? No, they don't need this from us. What do they need from us? They need the electron in box representation. What does it mean? This means you have to know that for S, how many boxes does it have? It has 1 box. P, how many boxes does it have? It has 1 big box separated into 3. D, how many boxes does it have? It has one really big box separated into 1, 2, 3, 4, and 5. F, how many does it have? It has one really big box separated into how much? Into 7. 1, 2, 3, 4, 5, 6. Hold on. It's 1, 2, 3, 4, 5, 6, and 7. So, how many boxes does S have? S has 1 box. How many boxes does P have? It has 3 boxes. How many boxes does D have? It has 5 boxes. How many boxes does F have? It has 7 boxes. Now, what is the point of each of these boxes? These boxes are used to put the pairs of electron. Whichever has a pair of electron will fill the box, right? But now, we're going to apply what? We're going to apply Hand's rule. What does Hand's rule state? Hand's rule state that the lowest energy level has the most unpaired electrons. How are we going to do this? First, let me erase this. And let us take this. It's 1s2, 2s2, 2p3, right? So, what are we going to do for each one? We're going to draw a box. First of all, for S, we have 1 box. And for P, we have how many boxes? 1 big box separated into 3. Now they're looking for the lowest energy level. Let us empty the electrons. This has 2 electrons. That means you will have 1 up, 1 down. This also has 2 electrons. This means you will have 1 up, 1 down. This has 3 electrons. How will we organize the 3 electrons? Very simply, you're going to have 1 electron here, 1 electron here, and 1 electron here. Why is this? Because you need to fill in every box before you move on to the pairing of electrons, okay? So this is a paired electron, this is a paired electron, and these are what? These are 3 unpaired electrons. Because of these 3 unpaired electrons, we can say that it has what? It has the lowest energy level. Why? Because it has the most unpaired electrons. So what answer matches what we have over here? A. So the answer very simply is A. Now, write the classification of nitrogen N. What do they mean by classification of nitrogen N? Because it has free or unpaired electrons, so let's say because it has free or unpaired electrons, okay, this is known as what? This is known as a free radical. So very simply, we will call this a free radical. Let's move on to question number 10. Which of the following is considered a free radical? Very simply, a free radical means that it has what? It has unpaired electrons. So, I will give you a hint when it comes to this question. When you look at the question and you think of a free radical, you will know that it has at least what? It has at least 1 set of unpaired electrons, right? Or at least like 1 unpaired electron. So, what does it mean unpaired electron? That means that the outer shell is not full. So unpaired electrons means what? That outer shell isn't full. Because the outer shell isn't full, this means it's what? It does not have noble gas configuration, right? So free radical means unpaired electrons. Unpaired electrons means outer shell isn't full. Outer shell isn't full means it does not have a noble gas configuration. Now, there are some elements, right, that also do not have a noble gas configuration, but they do have paired electrons. Like the outer shell is not full, right, but they still have paired electrons. In order to find out which one I will choose, very simply, first thing you need to do is you need to cross out anything with a noble gas configuration. What do we mean by noble gas configuration? We mean that anything that's a noble gas, for example, neon is a noble gas, or anything that has its ion, for example, K+. K+ is an ion, but if it's positive, that means it reached what? It reached its noble gas configuration. Why? Because the noble gas before potassium, K+, is argon. And how many protons or electrons does it have? It has 18 electrons. So if we take away 1 electron from potassium, that means it will reach the noble gas configuration of argon. So we definitely do not need this because it has a noble gas configuration. Same with Cl-. If you add 1 more electron to Cl17, you will get 18 electrons, which makes it what? Which makes it argon. Or it has a noble gas configuration. Just like that, in this question, we removed what? We removed all the options and we found our final option, which is what? Which is F9. Now, in the exam, if they give you 2 options, for example, they may get you Mg12, right? Both F9 and Mg12 are what? They are both not noble gases, right? So they are both not noble gases and they both don't have a noble gas configuration. But how do we know which one is a free radical? In order to determine which one is a free radical, we will need to do what? We need to first find out the SPDF configuration, okay? And after finding out the SPDF configuration, we'll be able to know which one is a free radical and which one isn't. So by now, you guys should know how to do the SPDF configuration by yourself. By now, you guys by yourself should know how to do the SPDF configuration of magnesium. It is what it is: 1s2, 2s2, 2p6, 3s2. If you want to double check, let's add all the electrons together. 2 plus 2 plus 6 plus 2. This will give us an answer of 12. As you can see, there is no unpaired electron. If you draw the box, you have 1 box, 2 box, 3 boxes, and 1 box. Do here, how many electrons? 1 up, 1 down. 1 up, 1 down. 1 up, 1 down, no, sorry, you don't do it like this. This is wrong the way I was doing. You do 1 up, 1 up, 1 up, 1 down, 1 down, 1 down, right? And then how many do you have here? You have 1 up, 1 down. As you can see, there's not a single unpaired electron. Because of this, it's not considered a free radical. But for example, if you were to do F9, it's 1s2, 2s2, 2p5. If you were to do it, it would be 1 up, 1 down, 1 up, 1 down, then 1 up, 1 up, 1 up, 1 down, 1 down, and you have 1 free unpaired electron. Because of this 1 free unpaired electron, you will call it what? You will call it a free radical. That's question number 10 done. So the answer here is F9. Let's move on to question 11. Which of the following have a half-filled subshell upon losing 1 electron? So here again, this will rely on you guys doing the SPDF method. So let's start first of all with Na11. It's gonna be what? It's gonna be 1s2, 2s2, 2p6, and what? And 3s1. But what did they tell us? They told us have a half-filled subshell upon losing 1 electron. So we will lose 1 electron from each of them. So you will take away this one because you lost 1 electron and you are left with this, right? So this is what? This is the configuration of an A after losing an electron. And as you can see, none of them are half filled. This is fully filled, this is fully filled, and this is fully filled. How do we know? This is 2 electrons, and 6 electrons. Just like that, you know that it is what? It is fully filled. Let's do Cl, 17, okay? We have 1s2, 2s2, 2p6, this is already 10, 3s2, that is 12, and 3p5. Now, they told us we will lose 1 electron. That means you will take away 1 electron from the last shell and you will change the number. So it was 5, it became 4. Why? Because we lost 1 electron. So let us see, this is full, this is full, this is full, this is also full, but this is not half full. In order for the P to be half full, you should have 3 electrons. Let us try with N, okay? N is what? 7. What is the configuration? 1s2, 2s2, 2p3, but you lose what? You lose 1 electron. So this, you will remove the 3 and you will put 2. Why? Because we lost 1 electron. As you can see, this is full, this is full, this is not half full, this is less than half full, because we need exactly half full, but this is less than half full. So you will also say, no, this is not the answer. So it leaves us for the last one, which is magnesium 12. Let me do it over here. Magnesium 12, again, do the electronic configuration. 1s2, 2s2, 2p6, and how much? And 3s2. This is exactly what? This is exactly 12, but you will lose 1 electron, so you will come to the s2, you will remove it, and you will put 1 instead. Let us see. This is full, this is full, this is full. Aha, this is what? This is half full. Why? Because it was 2 electrons, but we took away and it became half now, so which is 1. So definitely our answer is what? Our answer is Mg12. Let's move on to question number 12. What does it say in question number 12? It says, which of the following are true about 2px and 2py? First thing you need to know about them is they have the what? The same energy level, which is 2, same energy level n, which in this case is 2, and the same sub-level, which is what? Which is p. So they have the same energy level n, which is 2, and the same sub-level, which in this case is p. This is the first thing. Now, because they have the same energy level and the same sub-level, they are called what? Degenerate orbitals. Okay, this is all you need to know from this. So they are degenerate orbitals, and they are at the same energy level and sub-level. Let's move on to question number 13. They said, which of the following is the correct electron in box configuration with lowest energy? Meaning what? Meaning most unpaired electrons. Of which atom? Of atom O8. So let us take O8 and let us do first of all the regular configuration. You guys should know by now how to do this electron configuration. It's gonna be 1s2, 2s2, 2p4, okay? Now, look what we're gonna do. We're gonna draw the boxes for each one. This has one box, this has one box, this has three boxes. Or it's one big box divided into three. You start, this has one up, one down. This has one up, one down. This has one up, one up, one up, one down. So, what is the correct energy level, or like the correct electron in box representation for the lowest energy? It is the one that looks like this, where you have one up, one down, one up, one down, one up, one down, and then one and one. So the correct answer is what? The correct answer is A. Let's move on to question number 14. What does it say in 14? Sodium loses an electron with chlorine to become an ACl. So what's the shape of the orbital from which an electron is lost? Again, you guys should know the configuration of sodium. Sodium is Na11, right? So it is 1s2, 2s2, 2p6, and then what? 3s1. But they said what? They said that an electron is lost. So you will go to the last one and you will remove one electron. So this goes entirely. But from which orbital did we remove the electron? We removed it from orbital S. Orbital S has a circular shape, whereas orbital P has two domes together, two dome shape. Whereas orbital D has a clover shape. And then the last one, I think it's for orbital, I don't know what are the last two. Wait, the last two. The last two are actually also orbitals, but for orbital D. So, orbital D. Okay? Sorry for the B. Oops, what happened? So, anytime you see a clover shape, this is a clover shape, this is a clover shape. And when you see this, these clover shape, or this shape, you know that it belongs to orbital D. But for us, from which orbital did we take the electron? We took the electron from orbital A, which is what? Which is S. Let's move on to question number 15. What does it say in question number 15? Calculate the energy of a photon. What's the energy of a photon? Energy is equal to Planck's constant multiplied by V, which is the frequency. We have V, the frequency over here, and we have Planck's constant. We only need to multiply them together in order to get what? In order to get the energy. So energy is equal to 6.626 times 10 to the power of minus 34 multiplied by 6.11 times 10 to the power of 14. This will give us an answer of what? This will give us an answer of approximately, of course you have to round it to 3 significant figures, 4.05 times 10 to the power of minus 19, right? So it is what? 4.05 times 10 to the power of minus 19. So that is it for question number 15. Let's move on to question number 16. We've seen this so many times, way too many times. If you don't know this, it's a crime if you don't know how to do this. So choose the number of isotopes of the above element. How do we know what is the number of the above isotope? Or how do we know how many isotopes it has? You just count how many percentages you see. You see 1, 2 percentages, that means it has 2 isotopes. Move on. Calculate the average atomic mass of the element. Average atomic mass. How do you calculate average atomic mass? Very simply, average atomic mass, AAM. It's gonna be what? It's gonna be the relative mass. Let's just say the mass 1 multiplied by its percentage plus mass 2 multiplied by its percentage. Okay, this is how you can do it. So in this case, right, it's gonna be mass 1, which is 35 times its percentage, which is 75%, plus mass 2, which is 37 times its percentage, which is 25%. So 35 times 75% plus 37 times 25%. This will give us an answer of what? Of 35.5. Now check on the periodic table which element has a mass of 35.5. You will see chlorine. So the answer is what? It is chlorine. Let's move on to question number 17. Naturally occurring boron is composed of 2 isotopes. So now they gave us the isotopes and the average atomic mass. Now they want us to find what? The abundance of each percentage. So we know that average atomic mass is equal to mass multiplied by percentage plus mass multiplied by percentage, right? So average atomic mass in this case, which is 10.81, is equal to the mass. Always you take the mass number from the top. So 10 multiplied by the percentage. Let's say its percentage is x plus 11 multiplied by what? 100 minus x. What you guys need to know that this plus this is gonna give me what? 100. So x plus 100 minus x is gonna be equal to 100. Of course, why this and this cancel? So you'll get 100 is equal to 100. But what you need to know for now is that this plus this is supposed to give me 100. This is why I did x, and then the other one is what is 100 minus x. Now, let us solve. So it's going to be 10.81 is equal to 10 times x over 100 plus 11 times 100 is 1100 minus 11x over what? Over 100. Now, you can combine them together because they have the same denominator, right? So when they have the same denominator and it's addition, you can combine them together. Now, you'll move this to the other side. So now it's 10.81 times 100. This will give us an answer of 1081. It's equal to 10x plus 1100 minus 11x. Move this to the other side. We will get now what? You will get 1081 minus 1100, which is minus 19. So minus 19 is equal to what? Is equal to minus x. That means x is equal to 19%. Stop here. X is what? We assigned x for which one? For boron 10. That means this one is 19%. If this is 19%, then the other is what? It's 100 minus 19. What's 100 minus 19? It's gonna be 81. So this is what? 81%. Let's move on to question number 18. Give the relative charge of its nucleus, knowing that its atomic number is number of proton, is 90, and its mass number is how much? Is 232. Okay, so what you need to know when they ask you for the relative charge of the nucleus, you think of what are the things I have in the nucleus. In the nucleus, I have the nucleons. What are the nucleons? They are protons and neutrons. So neutrons don't have any charge. So when they ask me for the relative charge of the nucleus, I don't care about neutrons. I only care about the protons. How many protons do I have? I have 90 protons. When they say do not forget to include the sign, is it positive 90 or negative 90? It's positive 90. Why? Because we're dealing with protons, which are positive. So it's plus 90. Let's move on to question number 19. They said, write the atomic symbol of thorium. I've honestly not seen a question easier than this. You just do this. You write the element TH, and you write the mass number on top, 232, right? You write the mass number on top, 232, and on the bottom you write the atomic number, which is 90. We move on to question number 20. Okay, we have 80 boron, not boron, bromine. And let us look at the periodic table. What is the atomic number of bromine? It's 35. So 80 bromine, 35. How many protons does it have? It has 35 protons. How many neutrons does it have? 80 minus 35, which is what? Which is 45. Now, because we are dealing with an atom, bromine gas, it does not have a charge. It's going to have the same number of protons and the same number of electrons. So 35, 80 minus 35, which is 45. And then 35 again. Let's move on to question number 21. All atoms are made of subatomic particles. In an experiment, a beam of subatomic particles is passed between two oppositely charged plates and its behavior observed. The beam that deviates away, okay, here you have to pay attention to the keyword. When it deviates away from the positive plate, okay, we know that two positive will what? Will repel each other. And two negative will what? Will also repel each other. But one positive, one negative, they will attract each other, right? So if they're saying deviates away from the positive plate, that means its charge must also be positive. And which one is positive? The proton. Now, deviates away from the negative plate. If it deviates away, that means it has the same charge as this. So it also has a negative charge. That means it's what? It's an electron. Right? So this is proton. This is electron. And the last one, it passes without deviating. This, for all cases, it's a neutron. So pay attention to the keywords. If they said deviates towards, if it's going towards the plate, that means it has the opposite charge of the plate. But if it deviates away from the plate, that means it has the same charge as the plate. Let's move on to question number 22. Here you just need to know. Protons have a relative charge of +1. Neutrons do not have a charge. And electrons have a relative charge of -1. Whereas proton and neutron have the same mass, which is 1. And electron, their mass is so tiny we don't even consider it, but their relative mass is 1/1836, of course, AMU. The proton and neutron, their mass is small by itself. They don't even have a unit for it. They created AMU, just to say that, okay, it's 1 AMU. And then the electron is even smaller, so it's 1/1836 AMU, right? So that is it for this question. Let's move on to question number 23. Okay, again, what did we learn? We learned that s orbital have a sphere shape or a circle shape. The p orbital have what? Have two dumbbell shaped or two lobe shaped. And then d, okay, d, they have what they have. D has two shapes. It either has a clover shape, which looks, wait, I cannot draw it. It looks like this. This is a clover shape. Or it has what? It has two dumbbells and a ring or a donut in the middle. These are the two shapes of D. So that is it for this question. They want p orbital, of course, it's two dumbbell shaped. D orbital, it's a clover leaf shape, or it's the two dumbbell with the donut in the middle. And then s orbital, it is what? It is a circle or a sphere. Question number 24. Bohr, in his experiment, proposed that electrons orbit the nucleus in specific blah blah blah. Okay, this is a model. They're asking us calculate the maximum number of electrons that can occupy the fourth energy level. We said to occupy the energy level, that means that n, which is the energy level, is equal to 4, right? So first thing we got is that our energy level is equal to 4. Now we need to look at the equations. What's the maximum number of orbitals? If it's a maximum number of orbitals, we will apply the equation n squared. But since it's maximum number of electrons, it's going to be 2n squared, where only the n is squared, right? So 2 times 4 squared, 2 times 16, that's going to be what? That's going to be 32. Okay, so here, because they ask the maximum number of electrons, we will use the equation, which is what? Which is 2n squared. We'll go on to question number 25. This is easy. Subshell that can accommodate maximum 10 electrons is the D subshell. Move on to 26. Okay, here I believe this question is wrong because I checked with my friends, my fellow friends, and I did my research and I got this. I saw that the answer key was wrong, and I tried to solve it myself. It's also wrong. So please do check with your teacher. Maybe I'm mistaken because, again, I'm still a student, by the way. I do a lot of mistakes. I don't know the full course by heart, so of course I'm going to do mistakes. So please do double check with your teacher. Now, consider mgx where element x is in period 4. First of all, period 4 means basically what? Means basically row 4, right? And it's mgx. How do we know which group it is in? First of all, mgx. Let us take their ions. We know that mg is what? mg2 plus. In order for it to be what? In order for it to be a ratio of 1 to 1, x needs to be x2 minus. What do I mean by a ratio of 1 to 1? If I do the crisscross method, 2 plus and 2 minus will cancel, right? And I will be left with what? With mgx. This is 1 and this is 1, right? But originally, their ions are what? Their ions are mg2 plus and x2 minus, right? Now, they're asking us for the configuration of element x, right? Of element x. They didn't tell us ion. They didn't tell us with the charge. They didn't tell us what's it called? A cation or anion. No, they said of element x. Element x means that it is neutral. Okay, so now you will be asking, Amanda, so why did you do mg2 plus and x2 minus? Why did I do mg2 plus and x2 minus? I only did this in order to get x2 minus. Now that I know its charge, which is 2 minus, I will know that it belongs to group 6. Because in group 6, they all have a charge of -2. Now I have its group, which is group 6, and I have its period, which is period 4. So now I will open the periodic table, right? This is my periodic table over here, my very favorite. Okay, I will go to group 6. This is group 1, 2. This, you don't count it at all. This is group 3, group 4, group 5, and group 6. So this over here is group 6. And now we need to go to period 4. So you start counting. This is period 1, period 2, period 3, and period 4. So where does it intersect? It intersects at selenium. So what is our element? It is Se selenium. Now we will need to do the electron configuration of Se selenium. What is Se selenium? It's Se. What is the atomic number? It's 34. So for the element Se, we will need to do what? We will need to do the configuration. By this time, you guys need to know how to do it, okay? It's gonna be what? It's gonna be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p4. If you add all of the electrons together, what will you get? You will have 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 4. You will get a total answer of 34 electrons. Now, in the quiz, what did they put? They put all of this except for the last. They didn't put 4p4, they put 4p2. This, it's wrong. It's not 4p2, it's 4p4. Okay? But for the sake of the marking scheme, I'm going to put it as 4p2. However, the correct answer in the end is what is 4p4. So it's 1s2, 2s2, 2p6. This is how much already? This is already 10. Then 3s2, 12, 3p6, 18, 4s2, 20, 3d10, that's 30. And then finally, it's supposed to be 4p4, but in the marking scheme, it's 4p2. The answer is not 4p2, the answer is 4p4, but for the quiz, it is 4p2, okay? Let's move on to question number 27. Give the correct energy level diagram for aluminum. Okay, very simply. What we're gonna do in this case is we're gonna take the configuration of aluminum. We don't ever take the mass number, we only take the proton number. So it's gonna be 1s2, that's 2 electrons, 2s2, 4, 2p6, 10, 3s2, 12, and then 3p1. So how many in total is it? It is 2 plus 2 plus 6 plus 2 plus 1. In total, it is how many? 13 electrons. Right? Now, we need to make a box for each one. This is one box, another box. Here we draw one big box and we separate it into 3. Another box, and then we draw one big box and we separate it into 3. Now, how do we do this? How many electrons does this have? This has 2 electrons, so 1 up, 1 down. 2 electrons, 1 up, 1 down. 6 electrons, 1 up, 1 up, 1 up, 1 down, 1 down, 1 down. 2 electrons, 1 up, 1 down. 1 electron, 1 up. So it's supposed to look something like this, okay? So please remember this, write it on your copybook, and you will check the answers, right? So when you see the answers, you're supposed to see that 1s2, 2s2, that means this is wrong so far, okay? Then 2p6, that means now these two are wrong, and we are left with what? We're left with these two. And then 3s2, so this is correct. Why? Because they wrote 3s1. We don't want 3s1. So this is the correct answer. By the way, if you want to double check, you can see 1s, how many electrons it has? 2. 2s, how many electrons? 2. 2p, how many electrons? 6. 3s, how many electrons? 2. And then 3p, how many electrons? 1. The same exactly as our configuration. So which one is our answer? This one is our answer. Let's move on to question number 28. Right, the shorthand electron configuration of the following atom. So, whenever they say shorthand electron configuration, what does it mean? This means you will always, when they say shorthand, of course, and we're dealing with an atom, okay, you will always look to the noble gas before, okay? When we are doing shorthand electron configuration, okay, and we're dealing with an atom, we always look to the noble gas before. So now we're dealing with Fe26, and I want shorthand electron configuration, right? So look at the noble gas before Fe. What's the noble gas before Fe? It is argon, Ar. I wrote AF, my bad, Ar. How many electrons does argon contain? Argon already contains 18 electrons. So just by writing in brackets Ar, how many electrons did we remove? We removed 18. So 26 minus 18, we only have 8 left, right? But now it's the confusing part. So we said that we will always take the noble gas before. In this case, it's argon. And what's argon? 18 electrons. What I advise to do is to first do the electronic configuration of argon. Okay, what's the electronic configuration of argon? 1s2, 2s2, 2p6, that is 10, 3s2, 3p6, yeah, till here. So until here, we reached what? The electron configuration of argon, okay? It already has 18 protons, or 18 electrons. Now, we come to Fe26. We already had 26 electrons. We took away already how much? 18. We already did 18 electrons. 26 minus 18, how many do we have to do left? 8. So we have to fit 8 more electrons into this configuration. So what comes after 3p6? 4s2 comes after. And what comes after 4s2? Oops, my bad. I was gonna write 3p. No, it's 3d. So what comes after 4s? It's 3d. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d. How much? And 3d6. So now, if you add all of the electrons together, how much will you get? We have 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 6. We have in total how much? In total, we have 26. But if we want to write it in the shorthand electron configuration, we will take away the ones that belong to argon, right? Which is everything in green. So you will take it away. And you will replace it by what? By very simply brackets Ar, argon. So what is the finalized configuration of Fe26 in the shorthand form? It is argon 4s2 3d6. Okay, so argon 4s2 3d6. Amazing, that's 28. Now here's the thing. 29, we need to move on to question 29. 29 is what? 29 is a bit kind of like long question. But if you know how to do electronic configuration, it will not take you 5 minutes, okay? Let's first start with the Zn. We need to fill 30 electrons, right? So we start with 1s2, then 2s2, then 2p6. Like this, we already filled 10. Then after, 3s2, then 3p6. Now we filled 18 electrons. Then again, after, 4s2, then 3d10. And we stop here. Why? Because this is where we reach 30 electrons. If you want to double check, you can add it on the calculator. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10. And you will get an answer of what? You will get an answer of 30. So this is for what? This is for Zn. Let's move on to the next one, which is CO, cobalt. Again, you have to know how to do the electronic configuration. I'm not going to do for all of them. It's going to take me 10 years if I'm going to do them for all of them on the video. You guys should know how to do it. So after doing it, you're going to get 1s2, 2s2, not W, 2p6, 3s2, 3p6, 4s2, and 3d7. If you want to add everything, let's add everything. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 7. And you'll get a total of what? Of 27 electrons. Let's move on to Fe26. Okay, let's again, you guys should know how to do the electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d6. If you want to double check, add all of the electrons together. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 6. You will get in total how much? 26. Now finally for Si14, you also have to do the same thing. Okay, you guys should know how to do the electronic configuration. So 1s2, 2s2, 2p6. Oops, I clicked on the question. 2p6, 3s2. How many do I have now? I have 10 plus 2, 12. And then 3p, how much? 3p2. If you guys want to double check your answers, you can add everything. So 2 plus 2 plus 6 plus 2 plus 2, and you'll get a total answer of 14 electrons. Now let's move on to the final question. They said, removing a 1s electron from an oxygen atom requires more energy than removing one from a nitrogen atom. Why? Because oxygen has a higher nuclear charge. Now, what do they mean by this statement? Removing a 1s electron, meaning the electron that's closest to the nucleus. So let's say that this is oxygen. Oxygen, what is the mass of oxygen? 16, and it has 8 protons. So let's say 1, 2, 3, 4, 5, 6, 7, and 8 protons. And then how many neutrons? Also 8, because it's 16. The mass 1, 2, 3, 4, 5, 6, 7, and 8. So this is what? These are the nucleons. Okay, they have a total number of 16 nucleons and only 8 protons. And on the first shell, you will have energy level what? 1s. On the second energy level, you're going to have 2s and 2p and etc. So on and so forth. Now, removing a 1s electron, because it's the electrons that are closest to the nucleus, they will require more energy. Okay, first thing you need to know is that removing one s electron from the nucleus requires already a lot of energy. Why? Because it's closest to what? To the nucleus. But now they are comparing it to what? They're comparing the 1s electron between oxygen and nitrogen. They're saying that it requires more energy to take the 1s electron from the oxygen than from the nitrogen. Why is that? It's because of the nuclear charge. What does nuclear charge mean? Very simply, the number of protons each one has. Oxygen has a nuclear charge of +8 and nitrogen has a nuclear charge of +7. So definitely, if it has more electrons, it's gonna be harder in order to remove the electrons in the first energy level. Okay? So what did we understand from this? That the more nuclear charge or the more protons it has, the harder or the more energy we will need to remove a 1s electron. Why? Because it's the closest to the nucleus. Let us submit, and I'm praying we don't have any mistakes. It's gonna take a bit to submit. And thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed. Look at the time. Okay, the video is not this time, but this is me, how much I sat. I hope you enjoyed and have a wonderful day. So guys, I forgot to do a small recap of the equations. So I'm just gonna do it over here. The first thing that you need to know is that we have the energy of the magnitude is equal to the absolute value of the charge of the first ion multiplied by the charge of the second ion over the radius squared. This is one thing you need to know. From this equation, you'll be able to understand everything else. Now, what is another equation? The energy level, N. So depending on the energy level N, let's say you have energy level N, in order to find the orbital number, you will need to do n squared. In order to find the electron number, you will need to do 2n squared. Okay? Then, what do we have after this? We have that energy is equal to Planck's constant times V. V is what? V is frequency. Okay, and then V is equal to the speed of light in vacuum over lambda. And free radical means it has free or unpaired electrons. I'm just seeing if there's anything else I need to add. Oh yeah. For P, what is the shape of the orbital of P? It is 2 dumbbells. For S, it's a circle. For what's it called? For D, we have 2 shapes. We have either the clover shape, or we have what? Or we have the 2 dumbbell, and in the middle we have a donut. And oh yeah, the SPDF. Now, regarding the SPDF method, if you do want to do, like, there's 2 ways you guys need to know in order to do the SPDF method. First method is like this. S. First you write S, then 1S, 2S, 3S, 4S, 5S, and 6S. Let's stop at 6S. Then 2P, 3P, 4P, 5P, 6P, right? Then we move on to the next one. 3D, 4D, 5D. We stop at 5D. And then 4F, 5F. Here's where we stop, right? Now, always, if it's even, it will be the same as the one before. If it's odd, you need to add 1. Right? So we start with 0. 1 is an odd number, we will add 1, so we will take 1. Even, you will take the same as you took before. So here you took 1, you will go to the even. So this is the second arrow. How many you will take? You will take 1. So this is the third arrow. We will add 1 more. So now we will take 2. The fourth arrow, we will take the same number. So 4, we will also take 2. The fifth arrow, because it's odd, we will add 1. So we will take 3. The sixth arrow, because it's even, we will also take 3. And then so on and so forth. We're going to stop until here, right? This is one method of doing it. Another method of doing it is like this. You're going to start with S, and then S. And then PS, PS. And then D, P, S, D, P, S. And then F, D, P, S, F, D, P, S, right? This is how you do it. Now let's number them. 1, 2, 3, 4, 5, 6, and 7, and 8, right? Then, for the P, you start at energy level 2, so 2P, 3P, 4P, 5P, 6P, and 7P. Then, for D, you start at energy level 3, 3D, 4D, 5D, and 6D. And for F, you start at energy level 4, 4F, and 5F. Now, S always has 2 electrons. P always has, first let me finish the S, hold on. P always has 6 electrons. D always has 10 electrons. And then finally, F always has 14 electrons. And like this, you will be able to do it however you want. And it's already in order, look. As you can see, it's in order. You have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, etc., so on and so forth. So this is what the SPDF or 1s1, 2s1 configuration. Okay, so thank you guys for watching. I hope you enjoyed and have a wonderful day.